Hello students, welcome to the class of chemistry. Myself Dr. Shilpi Gupta. In my previous 9 videos, I have taught you the topic of alcohol, the complete alcohol with their mechanism. So please watch it and learn the topic of alcohol. Today, I am going to start the topic of phenols. Phenols is equally important as you have learned the topic of alcohol. Okay, so first let me explain you what is phenol. You all must be aware with this structure. This is a benzene ring. So when hydroxy group is attached directly to the nucleus of benzene ring, it is called as phenol. Okay, when hydroxy group is directly attached to the benzene nucleus, it is called as phenol. Phenol is also classified under 3 categories. First is monohydric phenol. As the name suggests, monohydric means one hydroxy group. Okay, so when one hydroxy group is attached to the benzene nucleus, it is called as monohydric phenol. Okay, this is simple phenol because only hydroxy group is attached to the benzene nucleus or aromatic nucleus. If any other substituents like I say nitro group is attached to the benzene nucleus on ortho, meta or para position, this is the ortho position, this is the meta position and this is the para position. If any other substituent is attached, then the name will be changed. Okay, but the parent name can be used in the suffix. Now this is para-nitro phenol. Okay, suppose I attached methyl group to the benzene nucleus. Now this is at the second position. It is at the second position. This is the first position. This is the second position. So it is 2-methyl phenol or 2-methyl hydroxy benzene. You can name it in any way. Okay. Now the trivial name of this structure is orthocresol. Okay. Then comes at the meta position. If the CH3 group is attached at the meta position, then it is called as metacresol. And the parent name will be 3-methyl phenol. 3-methyl phenol. Similarly, if the hydroxy group is attached at the para position. Okay, this is the para position. If the methyl group is attached at the para position, then it is called as paracresol or 4-methyl. For the first, we will give the name of the other substituent. Okay, 4-methyl phenol or 4-methyl hydroxy benzene. So this was monohydric phenol, which means then one hydroxy group is attached to the benzene nucleus. Now comes the dihydric phenols. It is classified under 3 categories: monohydric, dihydric and trihydric. Now comes the dihydric phenols. Dihydric means 2. So when 2 hydroxy groups are attached to the benzene nucleus like this, it is called as dihydric phenol. Okay, now we can name it as 1,2-dihydroxy benzene or phenol, or the trivial name of this structure is catechol. Similarly, if the position of the another hydroxy group changed and it comes here, then it is called as 1,3-dihydroxy benzene, or the trivial name is resorcinol. This is a very important. If the hydroxy group is attached to the para position, then the name change. It is called as 1,4-dihydroxy benzene, or it is also called as hydroquinone. Okay. Okay, so these are some very important structures which I am telling you. This is catechol, this is resorcinol, and this is hydroquinone. Okay, now comes the trihydric phenols. What are trihydric phenols? Trihydric means, tri means 3. So when 3 hydroxy groups are attached like this, it is called as 1,2,3 trihydroxy benzene. Okay, this is 1,2,3 trihydroxy benzene, and the tribal name is pyrogalol. Okay, if the hydroxy group changes its position like 1, 2 and it get attached on here at the 4th position, then its name change. It is called as 1,2 trihydroxy benzene. Okay, or it is also called as hydroxyquinol. And if the hydroxy group get attached like this at the 1, 3 and 5th position, then it is named as 1,3,5 trihydroxy benzene, or the tribal name is fluoroglucinol. Okay, so this was the classification of phenol: monohydric, dihydric and trihydric. It's completed now. Now we come on the next topic. The next topic is acidity of phenol. I have explained you acidity of alcohol in my previous topic. So here a question which always comes in, mostly comes in your exam, is why phenol is more acidic than alcohol. Alcohol is a very weak acid. Phenol is also weak, but in comparison phenol is stronger acid. Why? So we will do it now here. Acidity of phenol. So phenol actually in aqueous solution or itself dissociate into phenoxide ion like this. Acidity means giving proton. Okay, proton donor. So this is the hydroxy group in which oxygen is attached to the proton. But on dissociation with acid, it changes into phenoxide ion and it gives proton. Okay, why is it possible? And why not in alcohol? It was easily possible. So I explain you this. So the acidity of phenol depends on the resonance. Resonance is a very important term which I explain you today. Resonance is charge delocalization. The delocalization of charge means the negative charge spread throughout the ring is called as resonance. So phenol supports resonance. That's why it's possible that the acidity of phenol is possible. How? Now we'll do how. So first of all, as I told you that phenol this is phenol, it dissociates into a phenoxide ion. Now, like this. Now, this phenoxide ion should be stable. Otherwise, what will happen, like happened in alcohol, that if it is unstable, then it will attract the proton towards itself again. So, it will not be acidic. But this phenoxide ion is stable. Its stability is due to resonance. Resonance is charge delocalization. Okay, means the negative charge spreads throughout the ring and that's why it is stable. Okay, and that's why it is acidic. How the charge delocalize? Now I explain you this. See, this is phenoxide ion. Okay, how it happens? I explain you this. This negative charge first, it will come here. When this negative charge, these bonds are lone pair of electrons. These bonds are a pair of electrons. Okay, and this negative charge is also lone pair of electrons. So when this pair of electrons come here, then this bond, what is this bond? This is also pair of electron. So it will come at this point. This is a carbon point. Okay, this will come here. So a structure will form like this. This I am explaining you the charge delocalization. Okay, because the negative charge came here. So what happened? Double bond O. And this bond means this pair of electrons come at this point like this. Okay, it is like this. Now in the next step, what will happen? This pair of electron will come here. When it will come here, then this bond means the pair of electron will come at this carbon point. And the structure will form like this. This is double bond O. Okay. Now, as I told you, this will come here. So, it came here. And this bond, a pair of electrons will come at this carbon point like this. Okay. Now, in the next step, this will come here. And when it will come here, this will move to this carbon point. Okay. So, what will happen? A structure will form like this. This is like this only. Double bond O is like this. This bond came here and lone pair of electrons came at this carbon point. Now what will happen? This will come here, and when it will come here at this bond, then this is double bond. One double bond will shift to the oxygen and the structure will form like this. Okay. So negative charge spreads throughout the ring, means charge delocalization happens, and this phenoxide ion is a stable one. That's why it supports acidity. Okay, so acidity of phenol depends on the resonance, the charge delocalization. Okay, so for now it's completed, and now we will meet in our next video. Till then, goodbye, have a great day.